Hello, everybody. Thank you for joining us for our first season of NETCH Live from the Lab. Today's topic for our sixth episode is STA 449 F3 Simultaneous DSC TGA Dual Furnace Instrument Preparation Setup, Sample Setup and Preparation. I'll begin by showing you a brief introductory PowerPoint presentation. Following the presentation, my colleague Mike Sue will be giving a demonstration. After his demonstration is complete, we'll open it up to questions. So you can ask live questions as soon as his demonstration concludes. So let me show you the PowerPoint. All right. So, as I mentioned, this is our sixth episode. Again, this is STA dual furnace instrument preparation and sample preparation and setup. We currently have one more NETCH Live from the Lab episode planned covering the topics displayed on the screen. Unfortunately, we had internet connectivity issues for our episode 3. This has been rescheduled for November 11th. And just as a reminder, for the next season starting in 2020, we want to use these NETCH Live shows to cover topics that would be most interesting for all of you. In order to do that, we need your help. So please email nib_live@netch.com if you have any ideas for topics that you would like to be covered. You may also follow us on LinkedIn and Facebook, where we will be keeping you informed about any new NETCH Live from the Lab episodes and polling our viewers to get more feedback on topics of interest. So my name is Brad Hammond. I'm head of the Applications Laboratory here in Burlington, Massachusetts. We provide contract testing on NETCH instruments, and we also provide application support for existing NETCH customers. So we're bringing these demos to you live from our commercial testing lab. You can please reach out to us, and we're here for you to leverage our expertise in materials characterization. We consult with you to set up your testing as required. So you can send us your samples. We'll run the measurements, review the data, discuss the findings with you, and send you a report. Also, we recently achieved accreditation to the ISO 17025 2017 standard. So if you might know Mike Sue from our previous episodes, Mike is a senior application scientist here at NETCH. He'll be the one presenting today, and he has over 14 years of experience in material science. Mike has a vast knowledge of a wide breadth of materials, including polymers, ceramics, and metals. He's always happy to pass on his knowledge to our customers during advanced customer training sessions and helping with data analysis and interpretation. If you have any questions for Mike specifically, he can be contacted directly at the email address shown on the screen. So as I mentioned before, as soon as Mike's demonstration concludes, he'll be answering your questions live. So during the webinar and during the demonstration, please type in any questions you may have into the question box, or you can also email nib_live@netch.com, and we'll be able to see your questions from that email. So this is a brief overview of what he'll be talking about. Again, the dual furnace instrument preparation, sample setup, and sample preparation. He'll cover why you would want to have two furnaces. He'll go over some issues with crucible compatibility, cleaning, etc., and also where all this can be found, including in our catalog and on our website. So now, over to Mike.
All right, welcome to another episode of Live from the Lab. I'm Mike Sue, Senior Application Scientist here at NETCH Instruments. Last episode, we had discussed how to change some of the various sample carriers out of our STA units. Today, we'll also discuss a little bit further of the versatility of our STA units, namely the furnaces and some of the different accessories that, in terms of measuring capabilities of our instruments. Today we'll be discussing first about the dual furnace pivoting system of our STA units. So on my left here, we have an STA unit with how our dual furnace setup looks like. So we have one furnace here in the left position and one in the right. So our mounting system has the capability of either having two furnaces left and right, or here on this unit, we have a single furnace with an auto sampler on the other side. So the way that our dual system works is first I'll open up the furnace. So we have the safety button on the right and requiring your second hand to push the up button. So as we lift the furnace, once it reaches the top position, we are now able to swing the pivot system to be able to rotate to the second furnace into place. Now, once a furnace starts moving down, it will lock in place so that it won't be able to rotate anymore. So this prevents any user from accidentally making contact with the sample carrier, and only when the furnace is all the way in the up position can the furnace then be able to move from left or right. So now the next question is, why would anybody want to have two different furnaces? Well, the STA on our units have the capability of measuring from anywhere between -150 Celsius all the way up to 2,400 Celsius. And unfortunately, there isn't a single furnace due to heating element properties to cover the entire range in one single furnace. And therefore, NETCH has split up the different temperature ranges to accommodate each one of these ideal temperature ranges. So as an example, on my left furnace here, I have a steel furnace. So the range between the steel is from -150 Celsius all the way to 1,000. And then if I switch over to my right furnace, which is a silicon carbide, I can have a higher end top temperature range. So this one will run from room temperature to 1550 Celsius. Now we have a couple other furnaces here in our lab. So here on my left is a rhodium furnace. So this one can go to room temperature to 1650 degrees Celsius. And then here I have a platinum furnace, which can go from room temperature to 1500 Celsius. And then I'll just show a slide real quick on the computer screen, which showcases the entire suite of furnaces that NETCH has available. So if you wanted to go to even higher temperatures, we have the ability to go from room temperature to 2000 with a graphite, or up to 2400 degrees with a tungsten furnace. We also have a couple specialty furnaces for experiments that require humid atmospheres, or having steam as part of your gas purge flow. And so that is this water vapor furnace. And the water vapor furnace has a slightly different design, which allows the moisture not to interact with all the different components to damage other parts of the instrument, but it also minimizes the amount of condensation that might occur within the actual interior of the furnace. All right, so we'll go back quickly. So the way that I can kind of describe another reason why you would want different furnaces is if you think about vehicles. So let's say you wanted to go somewhere really, really fast. You might pick a sports car because they have high acceleration or high top speed. But now let's say I have 10 STA units that I want to transport to a customer, well, a sports car isn't really designed to transport a lot of cargo. So in that particular case, I might want to pick a truck. And so our furnaces kind of operate in the same manner, in which you as a user will have to determine what your particular application is, and then we would have suitable furnaces to cover those particular temperature ranges and those particular applications. So once we have determined what type of furnace we want to use in terms of the temperature range, the next part of the equation for sample measurement is picking the ideal crucible to run. So all of our crucibles that we have a maximum operable temperature. So for example, aluminum has a top range of 600 degrees Celsius. Aluminum oxide and platinum can go up to 1700 degrees Celsius. Now, if I wanted to run a sample measurement to 500 degrees Celsius, all three of these would be acceptable because they all are within the allotted temperature range. But if I wanted to run my measurement to 1200 Celsius, well, then I can't use aluminum because aluminum will melt at 600. So then my choices are ones that can hit those particular temperatures. And so let me go back on the computer screen again real quick. So in our instrument software, where you go to the instrument setup tab of the instrument software, we have a drop-down menu which shows crucibles, and every single crucible has the material name and the maximum allowable temperature to be measured. So each one of these has a specific value, and this is just to prevent you from exceeding the temperature allowed in the measurement. So our software also have safety nets, in which case when you indicate what particular crucible, as well as the software will detect what particular furnace you have equipped and the sample carrier type, and all these different selections have a maximum allowable temperature. So whenever you go to the temperature program page, if I wanted to create a dynamic step and put an end temperature, it'll give me what is the limiting factor. So in this case, I'm choosing aluminum, so I can only go to 600 degrees Celsius. But if I were to run with a aluminum oxide crucible, let's say, then it'll give me a higher maximum temperature. So this 1500 is my max, and that is due to the fact that my platinum furnace can only go to 1500. So the software will give you these restrictions so that you won't program a temperature that is not allowable, that might either damage one component or the other. So in our accessories catalog, so let me go back on screen. So in our accessories catalog, so we have PDF versions, but we also have these hard copies. In our accessories catalog, they also list the maximum allowable temperatures. So let me just show you a crucible page. And so in each column, so on the left column here is the material type. And then in the second column, it'll list the maximum allowable temperature for these crucibles. So for example, platinum rhodium can go to a maximum of 1700 Celsius. Aluminum oxide also to 1700, and then aluminum here to 600 degrees Celsius. So once you have selected both your furnace type, your crucibles, the next thing that you really have to consider is what are the materials that you are planning to measure. So the material that you choose can also dictate what type of crucibles are allowed. So also in our accessories catalog, we have compatibility charts. So these compatibility charts will give you kind of certain archetypes of materials and what particular crucibles might be compatible with. So in this particular chart, I have, let's say, oxide ceramics, and anything with check marks are okay. So platinum, rhodium, anything with a check mark plus a star means that reactions could be possible. So if I chose something like a metal or an alloy, I wouldn't want to use a platinum rhodium crucible because those materials might react and alloy with each other. So definitely utilize these charts as a reference and a guidance, but there are always going to be some exceptions. So in cases where I am dealing with either new research samples or unknown samples where I might not know what the possible reactions are or interactions with crucibles and the sample material, I'll start with small quantities such as 1 to 2 milligrams, run it through. Once the measurement is done, I will assess both the crucible and the material to see if any interactions occurred. If none occurred, then I can increase the sample quantity, and after each one of these iterations, I'll reassess. So sometimes it might not occur in small quantities, but larger quantities, you might have a different sort of kinetics and reaction that could also have some impact with your measurement. So the other question I get often is, how do I clean crucibles after measurements? So cleaning usually, if you're dealing with, let's say, aluminum crucibles, usually we consider these one-time use because we usually will crimp them shut or seal them. They kind of deform easily when you try to operate with them. And they are relatively inexpensive. So usually with aluminum, we don't try to clean them. We just use a fresh aluminum crucible. For aluminum oxide or platinum crucibles, these are a little bit more expensive. And so we tend to want to get multiple uses out of them if we can. And so the first thing that I'll try is to burn them out in air to remove any maybe organic contaminants. If that doesn't work, then you might need to use solvents, harsher solvents, and acids. As example, if you have glass materials that might fuse or adhere to platinum crucibles, sometimes the only way to remove that is to use HF or hydrofluoric acid to dissolve the glass. So usually, if you have an idea of some of the contaminants or the component materials, you can usually choose a particular solvent or acid that will help clean the crucibles. Now, after cleaning the crucibles, especially platinum, you might accidentally deform or warp the samples. So here I have a platinum crucible, and so I'm just going to demonstrate by squeezing it. If you accidentally squeeze it too much, or if you drop it and you dent it, so now my crucible is, let's see if I can get a better image of it. So it's not exactly round anymore. So we have a crucible reshaping tool. So it looks like this. So on one end, it's a little bit skinnier, and on the opposite end, it's a little bit fatter. So the fatter end will be the final shape of our round crucible. And so usually we'll use the smaller, skinnier end to push the crucible walls back out. So that's in an almost general round shape in which we can fit the fatter end over. So once I get the fat end over, I can then go on a countertop and roll it so that it's nice and round again. And so now I remove it, and I have a round crucible again where I can now put a lid on it and run more experiments on. So one other key item to mention is when we run DSC or specific heat type measurements, we tend to recommend using conductive crucibles, and usually those are the metallic type. So platinum is a good choice. For certain materials, such as metals and alloys, they're not compatible with platinum, and therefore we have thin aluminum oxide liners that can fit on the inside of crucibles. So let me grab one of these, and I'll grab the platinum crucible. So the thin alumina liner is this white disc here. And then these can fit on the inside of a platinum crucible so that we get the contact with the sample as a aluminum oxide, so it won't react with the platinum, but we still get the conductive heating properties of platinum so that you get good DSC signal and response. So the aluminum oxide liner fits right inside, and then you can put a lid right on top. Okay, so that's kind of a quick demonstration. I'm going to go check out some of the questions that you might have. So feel free to put some questions in, and I will start answering them. All right, so the first question is, does the instrument software identify the furnace automatically? So yes, all of our furnaces are connected with a cable in the back. So the cable goes directly into the instrument, and then the instrument is connected to the computer itself. And so when I am switching between the two different furnaces, the instrument will detect which one is in place. So just to demonstrate, give me 1 second. All right, so right now on screen here, I have the silicon carbide being detected. Let's see if I can put the screen a little closer. So I have the silicon carbide, which is the right one being detected. So if I switch to the left one, I can refresh, and it will detect that now I have the silicon, I would have the steel in place. So the other way that you can also change them up is in the instrument setup screen. So under the furnace tab of the instrument setup, there is a drop-down menu. And the drop-down menu will also allow you to select which which furnace is in place. Is it hard to remove Al2, the aluminum oxide liners out of the platinum crucibles? So usually if they are new, you might be able to tap them back out. Usually once you start measuring it, they will kind of get a little bit fused or kind of stuck together. If, let's say, you had a sample reaction and you wanted to switch it out, usually the way that we do it would be to crack the interior liner. So usually I would take tweezers and squeeze the walls so that the aluminum oxide liner would start to break into small pieces, and then the aluminum oxide liner can fall out. You can then use the reshaping tool to get your crucible back round again, and then insert a brand new liner inside. Next question I have is, what are the maintenance needs of the instrument for parts like thermocouples and balances? So for our thermocouples are mostly equipped on our sample carrier sensors. Usually these will last a fair amount of time, so you don't really need any maintenance. Usually what ends up happening is you have sample interactions with the sensor or the thermocouples, in which sometimes you can try a burnout clean to help remove some of the contaminants. But eventually the thermocouples may degrade, in which then you would need to swap out to a new sensor. What type of acid is safe to clean the alumina crucibles? Will acetic acid work? So acetic acid should work. I don't see any interactions with that. So also in the back of our accessories catalog, we have some information about practices to clean crucibles. Let me find that page. So towards the back, we have a kind of a cleaning the crucibles. So it gives you some information of what you can use to do some of your cleaning. The next question is, does the STA have gas mixing capabilities? So yes, so all of our STA units have 3 gas ports. So let me go onto the instrument screen here to show. So under, so if you see here, I have 3 different columns for gases. So all of our instruments have 3 gas ports. So you can attach different gases to each one of these ports. So the protective is this far right one. For protective, we recommend using non-reducing, non-corrosive gases and not pure oxygen. So any inert gas or even air is fine, just don't use pure oxygen. And then for the Purge 1 and the Purge 2, we can utilize any types of gases. We do have some notes about reducing and corrosive gases. If you intend to use that, please contact us and we can send you some of that information. Next is what acids to avoid. So the acids for cleaning are really dependent on the materials that you are utilizing. So for example, you wouldn't want to use aqua regia for the platinum type crucibles, but if you're using, let's say, HCl, you should be okay. So again, refer to the information in the back of our catalog for some of those cleaning advice. The question is, can I connect an evolved gas apparatus like FTIR or QMS to this? So yes, all of our STA units have the ability to equip evolved gas analyzers. So let's take the camera and pan around to some of those examples. So right here, I have an STA unit with a heated transfer line that's connected to a GCMS unit. So over here, I have a dual TGA unit with an FTIR and a GCMS. So our FTIR and our MS units can all be attached to our STAs. And then here, I have our STA unit with a QMS unit. And so since I forgot to mention this earlier, so we have a quick display here of some of the different crucibles. So the different material types, as well as the different varieties for our STA units. So on the left ones here are mostly the DSC type of crucibles. And then as we spoke on last episode with the sample carriers, we can attach DTA crucibles or large TGA beaker crucibles or TGA plates to those different carriers. And then here we have our calibration kits to do temperature and sensitivity calibration, and then our crucible reshaping tools. So do you offer hyphenation capabilities, third-party mass spec? So yes, it is possible to couple other manufacturers, FTIR and QMS and GCMS units. Usually it's a little bit more difficult in terms of connecting it because all of our units have heated adapters and a transfer line. So we would have to retrofit something that would be able to connect with those particular units. The other drawback of using third-party mass specs would be that you might not have the ease of having a one-click button to start both the STA measurement and the evolved gas simultaneously. So you might need to do multiple computer clicks to get both of them to trigger together. Whereas the NETCH units with the FTIR, with the QMS and the GCMS, when the STA measurement begins, all of the measurement software collecting data will trigger simultaneously with one click. The next question I have is, would a lytic crucible be an oxygen argon deficient environment regardless of your flow condition? So all of our DSC crucibles have the ability to have a pierced hole on top. So that doesn't necessarily mean your measurement has to be sealed. So for example, our aluminum low temperature crucibles that go to 600 degrees Celsius, we can crimp them shut. So you can have a sealed crucible in that case, but you could also puncture a hole through the lid of the aluminum, and then you would also then be exposed to whatever purge gas environment you are. So all of our high temperature crucibles, the aluminum oxide, the platinum rhodium crucibles, they do not seal. The lids just rest on top of the crucible, and all of those have a pierced hole. So it allows the gases of your sample to come out of the crucible, as well as if you want any interactions with the purge gases that you're running to interact with your sample. So let's say you run in an oxygen environment, you could have oxygen react with your sample. If you're using reducing atmosphere like H2 argon, you could have those reducing atmospheres interact with the sample. For DSC at temperatures less than 0 degrees using liquid nitrogen, I have problems for DSC signal cooling. So let's go over here to the, so for our STAs, usually we'll have a liquid nitrogen dewar attached with it. So here we have our CC300 unit. So usually running sub-ambient on our STA units, especially to lower temperatures, we recommend you utilize helium as your purge gas because helium has a little bit better thermal conductivity at those low temperatures, so you get better signal response and more stable signal. Also for cooling, because the liquid nitrogen does a pulsing effect, if you want to acquire cooling data on the STA, we recommend you use gaseous nitrogen because it'll do a continuous stream and your signal should be a lot smoother. So, so the two things I would recommend is to use helium as your purge gas and to use gaseous nitrogen for cooling. How could I improve DSC signal in a heating, cooling, heating cycle? So for our STA units, we have what we consider a large thermal inertia furnace, in which it takes a little bit of time for the heat to transfer from the heating elements to the sample stage. So in terms of trying to create a more reproducible profile, we recommend that you disable the STC function on your measurement runs. So if you see on screen right now, I have an STC column in your temperature programming. So normally we recommend you turn the STC option off during these STA runs so that you utilize the furnace's thermocouple to translate the heat to the sample carrier, whereas the STC function means that the instrument is trying to control the temperature at the sample carrier level. So if I go back here really quick. So at the sample carrier level, there's going to be a little bit of a lag between the heat from the furnace to the sample carrier. So at the start of any heat ramps or cooling ramps, there will be a little bit of a delay or a lag before the heat gets there. So the software is thinking, I'm not cooling or heating at the appropriate rate. So I'm going to increase that power to try to get it there. And then this creates overshooting and undershooting of the data of the temperature. And so you will get a little bit of sinusoidal temperature profile before it stabilizes. So the way that we mitigate that is to operate with STC off so that you don't get those large thermal lags. So the way to counteract, so the STC, because it's using the furnace thermocouple, and because there's a little bit of a thermal gradient to the sample carrier, we usually will have to program a little bit higher to the target temperature that you want. So if, let's say you want to go to 800 degrees Celsius at your sample level, and we have STC off, we may need to program our temperature program to be 850 with STC off. So our heating element will be at 850, and our sample carrier might just be reaching 800 at that particular point. Does protective gas have to be the same one with the purge gas? So the answer is no, it doesn't have to be. So the protective gas flows first through the balance of the chamber, which is down below. And then above the balance chamber, the purge 1 and purge 2 will mix with the protective, and then all of it will flow into the sample chamber. So the protective gas we recommend as the inert or air. And then purge 1 and purge 2, you can utilize other gases, which will mix together. But in the typical setup, if you just want to run measurements in one particular gas atmosphere, we usually will have protective and either purge 1 or purge 2 be the same. So if you see on screen again, so I have my protective here as helium, and then one of my purge streams is also helium. So if I was only to run in helium, then I would have both of these set. If I wanted to do helium and air together, then I would have helium here and air programmed as a gas flow value. Is it normal for the DSC signal to go steadily downwards with increasing temperature, linear heating? So it is not surprising if you see that. So the DSC signal is measuring the temperature heat flow differences between your reference crucible, which is in the back, and your sample that's in the front. So in an ideal perfect situation, your sample carrier would be sitting in the center of your furnace. Your heating elements would uniformly heat perfectly to both the reference and the sample crucible, but likely that's not going to happen. Your reference crucible might sit slightly closer to the wall of the furnace or vice versa, and that's where you might see some of those drifts, either upwards or downwards. So if it was ideally perfect, it would be perfectly flat, but we usually don't see it. So that's why we always recommend you perform a correction measurement with 2 empty crucibles. So this will collect the inherent baseline values of how your setup is occurring. And then when you perform a correction plus sample measurement, it will subtract out these signals so that you will generate the signals of just the sample. Is there a furnace thermocouple and a sensor thermocouple? So yes, there is a thermocouple in the furnace, and there's thermocouples on the sensor. And so that was the explanation of the STC option. So depending on which one is enabled, STC on or off, you will allow the software to dictate which one to control the temperature based on. For high heating rate furnace, are pyrolysis experiments for fossil fuels okay, or could they damage the furnace? And are the recommended use gas flows similar to the ones used in the water vapor furnace? So usually what I recommend when users ask me questions about sample measurements, usually first you want to have an idea of what could happen. So usually fossil fuels, if you're heating in, let's say, an oxidative environment, you might have a lot of exothermic reaction and heat. So in those situations, there could be some potential for damage to either the sensor or the equipment itself if it releases a lot, sort of like a kind of explosion. So you want to be careful. So usually what I recommend is starting with small quantities of sample, test it, and then assess after each run. And if you deem that everything looks good, then you can increase the sample quantity. In terms of gas flow rates, the STA unit, we usually recommend a minimum of 70 milliliters per minute flow rate total, in which 20 milliliters is in the protective, so that'll go to the balance. And then the remainder 50 can be in purge 1 or purge 2 or a mixture of them. So this is just to allow sufficient flow so that any evolved gases from your sample can be pushed up out the exhaust at the top. For specific other types of measurements, there are abilities to kind of increase the flow or decrease, so it really depends on what you're after. If you lower the flow rates, you'll have a higher concentration of gas, so you have less dilution of your sample evolved gases, which might be handy if you're dealing with very small quantities and using evolved gas analyzers to try to identify them. If you use higher flow rates, if you have very reactive type of gases that could potentially damage the sensors or the protective lining of your furnace, then using higher flow rates will dilute those to have less impact and less possible interactions with those. Do you use auto vacuum when you switch gases for STA QMS systems? So usually you have the ability to use auto vacuum. In terms of starting a measurement, I usually, for a QMS system, I'm operating usually in argon gas. Argon gas is usually much denser than the atmospheric gases, so allowing a long enough purge will push all the gases out. But you could effectively do the same with evacuation and backfill. I tend to choose not to do evacuate if I'm doing powder samples because I could end up sucking some of the powder out of the crucible. But in terms of just running evacuation, when I'm switching from, let's say, helium to a helium type of system where helium can't effectively purge out the atmospheric gases or the prior purged gas, then I will use an evacuating and backfill before I do the measurement run. So the question is, just to clarify, when should the STC be off in the software again? So the STC is just a temperature programming option. You can choose to use it on or off. Usually with the STA system, we recommend during dynamic steps, we turn it off so that you have a more linear heating profile. When we go to, let's say, hold that isothermal at a specific temperature, so I ramp and I go to 1,000 degrees C, and I want to hold my sample at 1,000 C, then we can do the isothermal with the 1,000 and then turn the STC on, so to make sure that our sample stays at 1,000 degrees C. So usually that would be the case when I turn STC on and off, is if I want to hold my temperature at a specific temperature value. And then during the linear heating and cooling ramps, I'll turn STC off. Do you offer preventative maintenance plans or remote support plans? So yes, so that would be with our service team. So we do have service plans for preventative maintenance. So please get in touch with your sales rep and they can discuss options there. So using a purge 50 milliliters of nitrogen and 20 milliliters of protective, how much time is required for filling the instrument with purge? So roughly our total system balance and furnace system is roughly about 3 liters in volume. So usually I'll give it at least about 10 to 15 minute purge in order to get all the atmospheric gases out of the system. So you can always increase your flow rates to push out those atmospheric gases faster. But if you're just using the default 70 milliliters per minute, I would recommend 10 to 15 minute wait. Okay, I think that's all the time for questions we have today, so I'll turn it back to Brad. If you have any further questions, please email us at nib_live@netch.com. And thank you for tuning into this particular episode.
All right, thank you, Mike. So I'll just close it out with a couple more slides. So again, thank you, Mike, for that demonstration, and thank all of you for your time and attention. We want to let you know that all registered viewers may obtain a free 30-minute online help session, again, by contacting that nib_live@netch.com web address or email address, sorry. Please be sure to type furnaces in the subject line. And you can also email us with any additional questions that we were not able to answer during the live question and answer session today. I'll mention it again. Please let us know what it is that you want to see for future episodes. This is really for all of you. So we're asking for your feedback and for you to let us know what episodes that all of you would like to see. And you can also schedule virtual lab visits with us directly on our website. And any of our previously recorded webinars are also available. They're posted as webcasts on our website. And please check out that section of our website for future episodes. Thank you, and we hope to see you at the next episode.